Hello guys, my name is Mohammed Izhaan Khan. Currently, I'm pursuing my degree in Civil and Environmental Engineering from IIT Patna. I think my board is a little dirty, so I have to just clean it. We were solving the exemplar questions of the topic continuity and differentiability. In the last class, I had done till question number 80, I think, and we had to start from the objective type of questions. So today we'll take on from there and we'll try to finish it off today. All right. So let's see how many questions are there. Not many questions are there. We'll just do it slow and we'll finish it off. All right. So starting off from the So the objective type of questions 83. All right. So just question number 83. So what is there? We have fx given to me as 2x and gx has been given to me as x square upon 2 plus 1. Now they are asking us which of the following can be a discontinuous function. All right. What are they talking about? They are talking about discontinuity. So first of all, tell me one thing. If f is continuous and g is continuous, you will clearly see that f and g are continuous because they are polynomial functions, right? So f plus minus g will be continuous as well. All right. F into g will be continuous as well. All right. Now, what are we left with? We are left with g upon f. Why will it not be continuous? It will not be continuous when f will be equal to 0. So then f is equals to 0. Like x is equals to 0, fx is equals to 0. Then g upon f will be discontinuous because it is not 0 by 0 form also. All right. Gx is 1 and fx is 0. So discontinuity is at x equal to 0. Got this? Now moving on to the next question. Question 84. Function fx. Fx has been given to me 4 minus x square whole divided by 4x minus x. Now 4 options have been given to me saying that it is discontinuous at only one point. It is discontinuous at exactly 2 points, at exactly 3 points, and none of these. So what will be the answer for this? Okay, so 4x minus x cube, which is in the denominator, that will be discontinuous at x equal to 0. Let's see. For discontinuity of this function, this should be equal to 0. So 4x minus x cube is equals to 0. If I take x common, this should be equal to 0. That means x is equals to 0. And 4 minus x square equal to 0. That means 2 plus x. 2 minus x equal to 0. That means x is equals to 2. X is equals to minus 2. So I've got 1 value, 2 value, 3 value. So discontinuity has 3 values. So the function f given to me is fx is equals to mod 2x minus 1 sine of x is differentiable. Okay. So this will always be differentiable, but not at the point when mod x is equals to 0, we get a king, right? This is the point for discontinuity. So we have to check at only the point where this thing inside is going to be equal to 0. That means 2x minus 1 is equals to 0. That means x is equals to 1. This is the point where you have to check. Alright. So let's check for differentiability. Okay. So if I quotient the right hand side for f dash of I can write it as limit h tends to 0 f half plus h minus f half whole divided by h. So limit h tends to 0 to by 2 plus h minus 1 sine half plus h, and f1 by 2 will be equal to 0. Alright, whole divided by nh. So limit h tends to a 0, mod of 2h times sine 1 plus 2h upon 2 whole divided by h. So mod 2h will be 2h sine 1 plus 2h upon 2 whole divided by h, and limit h is tending to a 0. So when h is tending to a 0, I can write it as 2 sine 1 by 2. Alright, this will be my answer for that. This is for the right of dash half. Now, if I find left of dash half and they both come to be equal, then we can say that the function is differentiable at that point. Okay, so limit h tends to 0. Same formula, f half minus h. Okay, and minus f half whole divided by h. Okay, so limit h tends to 0. 2 times half minus h minus 1 sine half minus h whole divided by minus h. So it will be again 2h sine half minus h divided by minus h. So now this time it will be minus 2 sine half. Alright, so L f dash is unequal to R f dash. That means it is discontinuous. At what point? At x is equals to 1 by 2. Alright. Now let's see the next question, question number 86. Yeah. So in question number 86, the function fx is equals to cot x is discontinuous on the set. We have to just tell the set. So what is cot x? Cot x is cos x upon sin x. So wherever sin x is equals to 0, the function will be discontinuous. And where is sin x equal to 0 at x is equals to n pi, where it belongs to an integer set. So the option A is the correct answer. Now question 57. The function fx is equals to e. F is equals to e raised to the power of mod of x is continuous everywhere, continuous and differentiable, not continuous, none of these. Okay. All right. See, it will be continuous to everywhere because the mod makes it continuous, but it makes it discontinuous at the point where it is making a key. So we have to just check. Okay. See, mod x and ex, and just e raised to the power of something, this are continuous. Therefore, e raised to the power of mod x is continuous. Alright. But talking about differentiability, at mod x equal to 0, this is not differentiable. So this makes this not differentiable where mod x is equals to 0. Alright, got this point. So the correct option is option A for this. Moving forward, question number 88. So it has been given that fx is equals to x square sine 1 by x, where x is unequal to 0. Then the value of the function f at x equal to 0, so that the function is continuous at x equal to 0. Alright. So इसको continuous करूँगा at x equal to 0. So if I put limit x tends to a 0, so x square will give out a 0 value and sine 1 by x will oscillate between minus 1 to 1. So this whole thing comes out to be a 0. So the answer will be 0, A. Let's move on to the next question. So I have fx given to me as mx plus 1 for x being less than or equal to pi by 2 and sin x plus n for x being greater than pi by 2. Now we have to check if this is continuous at x is equals to pi by 2. Alright. Okay. So, okay, we should check the first left hand limit. Left hand limit will be x tending to pi by 2 negative or mx plus 1. Alright, this is the function that will come in place when we will approach the left hand side. Alright. Now, what happens? So, if you write it here, limit h tends to a 0 and pi by 2 minus h, alright, plus 1. So I can write it as m pi by 2 plus 1. Alright, simple enough. Now, if I go for the right hand limit, so limit x tending to pi by 2 positive, and the function that will come in place is sin x plus n. Limit h tends to 0, sin pi by 2 plus h plus n. Okay, so limit h tends to 0, cos h plus n. Okay, so this will be equal to 1 plus n. So if it is continuous at pi by 2, then LHL should be equal to RHL. So my RHL is 1 plus n, and what was my LHL? It was n pi by 2 plus 1. Okay, so my m pi by 2 is equals to n. This is the condition that must be satisfied. Is equals to m pi by 2. So option C is the correct answer for this. Okay, so now moving forward to question number 90. So in question number 90, it has been given to me that function fx is equals to mod of sin x. So then you have to just tell that if f is differentiable everywhere, somewhere, okay, let's see. Again the same logic. Sin x and mod x are continuous everywhere. This is clear, right? Here we have to talk about the differentiation. But mod x is non-differentiable at x is equals to 0. That makes mod of sin x not differentiable when sin x equal to 0. That means again x is equals to 0. Okay. So at x is equals to n pi, where n belongs to z, fx is continuous but not differentiable. So the correct option will be option B. F is everywhere continuous but not differentiable when x is equals to n pi, where n belongs to z. Question number 90 first. Y has been given as a log, and then we have to just differentiate it. Okay. Okay, so I can write it as y is equals to log 1 minus x square and minus log 1 plus x square. Alright, this is clear. Yeah. So if I differentiate it, I will have this. So the correct option will be option B. Alright, moving forward to question number 92nd. So suppose that y is equals to under root of sin x plus y. Then what will be the value for dy by dx? Okay. Y square is equals to sin x plus y. And if I start differentiating it now, 2y dash, 2y dash is equals to cos x plus y dash. If I take y dash common, I'll be left with what? There will be cos x and there will be 2y minus 1. So 2y minus 1. So is there any option? Yeah. Cos x divided by 2y minus 1 is option number A. So now question 93rd. The question 93rd. the derivative of cos inverse 2x square minus 1 with respect to cos inverse x is, I taught you how to do these kind of questions, okay? You can just take the reference from there. Like you take u is equals to cos inverse 2x square minus 1. First I find du by dx, then I'll find v is equals to cos inverse x. I'll find du by dx, and then I'll find du by dv. Simply by dividing both of them. Okay. Now, one method is that, and anything else can you do? See, there is x inside over here. So I can write x is equals to cos v in the, and then u and v will be all that I'll be left with. So 2 times cos v ka whole square minus 1. Okay. Okay, so it is getting simpler for us. You'll see. Now I can write it as u is equals to cos inverse. See, this is what? 2 times cos square v minus 1. This is nothing but cos 2v. Alright, so I'll be left with 2v. So u is equals to 2v. And we have to find what? Du by dv. So just differentiating du by dv, I'll be left out with a 2. Alright, so this is your answer. So 24th. X is equals to t square, y is equals to t cube. Then we have to find d2y by dx square. Okay. So dx upon dt will be what? 2t. And dy by dt will be what? It will be 3 times t square. Alright, now this is the point where you have to find dy by dx. Do not differentiate it further because it will be dx square upon d2t, dy square upon d2t, and then when you differentiate it, it will be dx square upon dy square. Okay, and what do you have to find? You have to find dy square upon d2x, d2y upon dx square. That is what you have to find. I must have swapped the naming of the numerator and denominator. So just think accordingly. Okay, whenever you have to find this, d2y upon dx square, do not differentiate dx by dt, comma dy by dt 2 times and divide. This is not to be done. Okay, this is a very like ill blunder. So what do you have to do then? We just have to find dy by dx first. Okay, then we'll differentiate it with respect to x. Okay. So what will be dy by dx? Dy by dx is equals to 3t by 2. Alright, now differentiating it further with respect to x, I'll be left with what? d2y upon dx square and 3 by 2 dt by dx. Alright, so dt by dx was what? See, from here 1 upon 2t. So 3 by 2 into 1 upon 2t will be 3 upon 4t. This is your answer. Alright, moving forward, jumping on to question number 95. So question number 95, the value of C in Rolle's theorem for the function fx is equals to this in the interval 0 to root 3 is what? So Rolle's theorem, I already told you, since the fx is a polynomial function, so it will be continuous and differentiable as well. And we just check f0 is equals to 0 and f3 is also equal to 0. So, so it is clear to us. All right. Yeah. So there is at least one value between 0 to 3. There will be at least one value where at least one value c where f dash c will be equal to 0. This is Rolle's theorem simply put. So if I differentiate it, I'll be left with 3c square minus 3 equal to 0. C square is equals to 1 and c is equals to plus minus 1. But only plus 1 will be between 0 and 3. So the value where Rolle's theorem is applicable will be at x is equals to 1. And why not at x is equals to minus 1? Because the option has been given to us over here. It is minus 1. See, the domain that you have been given here is 0 to 3. So this value c will come between these now. Suppose this is 0, this is 3. So somewhere here, this value will come. So it can only be plus 1. It cannot be minus 1. Alright. Okay, so question number 96. For the function fx is equals to x plus 1 upon x, where x belongs in 1 to 3. Okay, the value C for mean value theorem is okay. For mean value theorem, we have to find f dash C is equals to fb minus fa whole divided by b minus a. So 1 minus 1 upon c square is equals to 10 upon 3 minus 2, 3 minus 1. C square minus 1 upon c square is equals to 2 upon 3. In this, I will get what? 3c square minus 2c square is equals to 3. C square is equals to 3. C is equals to under root 3. Plus 1 is under root 3, but the domain given to us is 0 to no. It is from 1 to 3, so it will be positive under root 3. Option B will be the correct answer. Now, what do we have? Okay, 97. Fill in the blank type questions. An example of a function which is continuous everywhere but fails to be differentiable exactly at 2 points. Okay, at 2 points it must be. Simply think of it like this. इतने example अभी हम लोग मिले we have taken so many examples. We've seen that the mod function is continuous everywhere, but it is not differentiable when whatever is inside x is equals to 0. Alright. So it is asking what? An example which is continuous everywhere but fails to be differentiable exactly at 2 points. So it will be what? I'll say x square minus 1 is equals to 0. Wherever this is a function of x, and wherever this is equals to 0, x can be equal to plus minus 1. So at 2 points, this is just not differentiable. Suppose I ask for 3 values. Like it is not differentiable for 3 values. So x2 minus 1 I will take. Okay, got this? How do we make these examples? At 2 value, 3 value, 99 values. If they ask me for 99 values, I can start it like this. Alright. Okay, so moving on to question number, this was 97, now 98. So question number 98. What we have derivative of x square with respect to x cube. Okay, so u is equals to x square, v is equals to x cube, and du by dx is equals to 2x, and dv by dx is equals to 3x square. Now du by dv will be equal to 2x upon 3x square. Simple algorithm, simple procedure. 2 by 3x will be the answer. Moving on. Question number 99 has given to us that fx is equals to a mod of cos x, and then we have to find f dash pi by 4. Okay, so for 0 to pi by 2, cos x is equal. Cos x is positive, so I can remove this. See, we have to find where f dash at x is equals to pi by 4. So if I restrict the domain for this, domain is only from 0 to pi by 2. This is the domain where cos x will be greater than 0. Okay, greater than equal to 0. So I can remove this mod because it is already positive. So cos x, now I can differentiate it. Cos x will be minus sin x. If I put the value for x is pi by 4, I'll be left out with minus 1 upon under root 2. Okay, so see, function had a mod in it, but the answer came out to be a negative. See, this is the beauty. Now, question number 100. 100 question has fx is equals to mod of cos x minus sin x. Where we have to find this? At f dash 5 by 3. Okay. So if I restrict the domain, from pi by 4 to pi by 2, see, this is the region. This is the region where cos x is less than sin x. Or later, this is the region where sin x is greater. So if sin x is greater, that means the mod opens up to the negative value, right? So I'll just open the mod. It will be sin x minus cos x for this domain, and then I'll differentiate it. It will be cos x plus sin x. Putting the value of pi by 3, this will be under root 3 by 2, and this will be 1 comma 2. So under root 3 plus 1 by 2. Okay. Now 101. Okay, so there are 106 questions only. So 101. For the curve that has been given to us is under root x plus under root y is equals to 1. And what do we have to do? We have to find dy by dx at 1 by 4 comma 1 by 4. Alright, nothing. I'll just differentiate it. So on differentiating with respect to x, I'll be left out with what? Under root y and dy by dx is equals to 0. So dy by dx is equals to minus 1 upon 2 under root x into 2 under root y and minus 2 under root y upon x. So if I put the values, that is 1 by 4, 2, 1 upon 4, 1 by 4, it will be 1, 1 by under root will be 1. So dy by dx is equals to minus 1. Now, state true and false for the statements in each of the exercises. X or shape. Alright. So, first of all, we have 102. Rawls theorem is applicable for the function fx is equals to mod x minus 1 in 0 to 2. Yeah. So question number 102. Rawls theorem is applicable for the function this in 0 to 2. No, because at x is equals to 1, see, where this will be discontinuous when x will be equal to 1. This comes between these numbers. So that this means that fx is not differentiable in the domain that has been given to us. So Rawls theorem is not applicable. So first answer will be false. If f is continuous on its domain D, then mod f is also continuous on D. Obviously, continuity तो होती है. See, f is continuous, then mod f is continuous or not. Think of it like this. Suppose there is a number x square. This is continuous. Alright. There is a number mod x. This is continuous or not? What do you think? See, this is the graph. If you approach from the left hand side or from the right hand side, you approach the same point. So it is continuous. It is not differentiable due to the king. Okay, you cannot find the slope at the king. So it is continuous. So if you put this inside over here, it will be continuous as well. No? So that is, if f is continuous on this domain, then mod f is also continuous on B. Obviously true. We have the composition of two continuous function is a continuous function. Composition of two continuous function, yes, true. If f is continuous, g is continuous, then f plus minus g and f into g is continuous, and f upon g is also continuous, but g should not be equal to 0. For this, similarly, g upon f is also continuous, but f should not be equal to. Trigonometric and inverse trigonometric functions are differentiable in their respective domain. Obviously, true. Nothing to explain over here. Now, f into g is continuous at x is equals to a, then f and g are separately continuous at x is equals to a. No, this we cannot say. See, suppose f dot g is continuous at x is equals to a, then we are asking that f and g are separately continuous at x is equals to a. I can prove how this is not possible. Suppose there is a function f. F is equals to, let's say, x square upon x minus a, and g is x minus a upon x cube. Now, when you find f dot g, what do? X square upon x minus a into x minus a upon x cube. So g will be 1 upon x. Now this is continuous. At x is equals to a, this value will be continuous. But Did this and this was continuous? This was continuous, I agree. But was this continuous at x is equals to a? No. So that is all. We have solved the whole exemplar questions. Now, I think that we should solve some PYQs, alright? So I'll just open them up for you. Continuity, differentiability.
ईजान व्हाट्सएप चेक कर लीजिएगा प्लीज एक बार.
Yes, sir, yes, sir. मैं देख रहा हूँ. Okay, so we'll start off with some PYQs. Let me just so the first question will be, you have to tell me the value for limit x tends to a 0, 1 plus x raised to the power of 1 by 3, and minus 1 minus x raised to the power of 1 by 3, whole divided by nx. Alright, so this is your question. So, what method can you apply to solve this? Think of it. So, can you see that this is the a cube minus b cube form? Alright, and if I just multiply it such 1 plus x raised to the power of 2 by 3 plus 1 minus x raised to the power of 2 by 3 and plus 1 plus x raised to the power of 1 by 3 into 1 minus x raised to the power of 1 by 3. The same thing will be in the denominator as well. Now, if I just multiply it, this is a cube minus b cube, and this is its complementary function. So it will be 1 plus x into 1 plus x minus 1 minus x whole divided by the whole thing. Okay, what will be the whole thing? X times this thing that I had written over here, 1 plus x raised to the power of 2 by 3 plus 1 minus x raised to the power of 2 by 3 plus 1 plus x raised to the power of 1 by 3 dot 1 minus x raised to the power of 1 by 3. All right, simple enough. Now, the numerator will be 2. All right, as you can see, numerator will be 2. And when I put value for x is equals to 0, minus 1 is 2x. 1 minus 1, 2x. X and x will get cancelled out. And whatever the x are inside over here, we can just put x ki value equal to 0 because it has been given to us that limit x is tending to 0 plus 1 plus 1. Now the answer will be finally 2 by 3 for this question. So the main trick was to identify that this is the a cube minus b cube form. Alright. So these are basically simple kind of questions, and I'm trying to find the questions for the JEE Advanced. Alright. JEE Advanced PYQs I have them somewhere. Okay, so now I'm starting off with some questions of JEE Advanced. Okay. So you know the basic concepts already, and so basic concepts are just run over to you wherever they come. Alright, but you need to maintain focus now. Try these questions when I write them down, so you'll see where you are lacking and where there is like a lack of concept or lack of practice. Where it is, you'll find out. Okay, but in order to do so, you first have to try those questions yourself. Okay. So the first question will be on property. No, property questions are a little more conceptual. So I want to try some question out for your practice. So this question for advanced 2019. Okay. So R to R is a function. Alright. So इसकी property 1. Prop 1. Limit h tends to 0 पे fh minus f0 whole under root mod h exists and is finite. What this property one understood that the limit for this whole thing at s tending to zero that exists and it is finite. And what is the property two? Property two is limit h tends to a zero, fh minus h zero h square. ये भी exists करेगी, it exists and is finite. Alright. So then which of the following options are correct? Option A कहता है कि fx is equals to x is to the power 2 by 3 has property 1. B कहता है कि sin x has prop 2. C कहता है mod x has prop 1 and D option कहता है x mod x has prop 2. So basically we have to check for each of these functions whichever property they are satisfying. Okay, so it is a time consuming problem. So first of all, if I take the first function x raised to the power of 2 by 3, so you can just pause this video right now and try out these questions. All right, because there is a live session, I have to continue. All right, but you have to pause this video right now and try this question for at least 5 to 10 minutes. All right, it is a lengthy question, I agree. And now I'm giving you the solution, which is to be watched after you have tried it yourself. All right, so moving forward. So the first function was fx is equals to x raised to the power of 2 by 3. Only now if I have fh can be written as this and limit h tends to 0, it will be h 2 by 3 minus 0 upon the root of mod of h. Alright, this was given to me. Now I can write it as, if something is written as like this, h square 1 by 3, then what can we do? What is to be done? You can write it as h2 by 3. And now I have mod inside and there's an under root sign over as well. So I'll just write it like this. Like mod will come out, all right. And since there's a square in it, it is a mod as well. See, this is just what I'm writing. The value for h raised to the power of 2 by 3 can never be negative. So I can write a mod for it. There is no anything bad in it. And similarly this. So just so that we can cancel these both terms out. So limit h tends to 0, mod of h 2 by 3 minus 1 by 2. So limit h tends to 0, mod of h raised to the power of 1 by 6. So this is equals to 0. So this is finite and it exists as well. So option A is correct. Okay, so it is an MCQ type of question. So you have got one option correct right now. Moving onwards. So what is the next function? Next function is sin x. Next function is fx is equals to sin x. Alright. So sin x is the नीचे वाला function. So limit h tends to 0. H tends to 0. Sin h minus 0 whole upon h square. Okay. So this comes out to be limit h tends to 0. 1 upon h into limit h tends to 0. Sin h upon h. This is the identity given the value comes out to be 1. So we are left with what? H tends to 0, 1 upon h. This comes out to be 1 upon 0. This comes out to be infinity, which is neither finite nor the other condition that was given to us. Okay, so option B is not correct. Okay, so in the exam, it is as much important to find out the options which are not correct as it is important to find the options which are correct. Why so? Because suppose you put the option correct, all right, you go through option B and you solve it in some manner that you operate with a blender. All right. If you do so and you find that option B is also correct, what will you do? There is a minus 3. Sometimes there is a minus 3 G advance. Okay. So you got 1 marks in option number A, but since if you left the question as it is, you don't know the answer for C and D, you left it as it is, you got 1 marks. Okay, it is good. But if you take the option B, which is wrong, Instead of getting plus 1, you get a minus 3. So this is a loss of 4 marks. Okay. So now moving onwards with option number C. So whenever you find an option and you find it incorrect, be happy. All right. So option C, limit h tends to 0. I have mod h, again mod h 1 by 2. Okay, I'm just going through it quickly, so I have to tell you the solutions for it. If I just be too slow, then mod h raised to the power of 1 by 2, putting value equal to 0. So this exists, need to find it. So you have other option as well. Option C is also correct. Okay. Now moving forward to option number B. So option D has been given x mod of x. Alright. So limit h tends to 0. H mod h minus 0 all divided by x square. So limit h tends to 0 mod h upon h. Okay. So इसकी तो दो वैल्यूज हो जाएंगी. It can be +1 and it can be -1. +1 for what? Where h is positive, h being greater than 0, and for h being less than 0. No, not h. For h being equal to 0, there will be a different concept. So option D is also not correct. So we have found the solution. A is correct and C is correct. If you have marked this, +4. And +4 in G advance is okay. So moving onward, this is the question for 2020 advance. So limit x tending to, it is a lengthy question. Like, so in numerator we have 4 under root 2 sine 3x plus sine x. Alright. In denominator, what do I have? 2 times sine 2x sine 3x upon 2 plus cos 5x upon 2. Alright. And minus under root 2 plus under root 2 cos of 2x plus cos 3x upon 2. Okay, so this is the question. Pause this video right now. Try for at least 5 to 10 minutes. Even if you try it for half an hour, it is for you won't benefit. This is the time that you are not wasting. You are learning too many things. You don't recognize that. So it is an integer type of question. Integer type question. Integer type question carries a +4 usually. See, nobody can tell you the exact weightage of whatever kind of questions we have because it varies from here to there. So usually it carries +4 and a 0 for negative. So it is a question. These kind of questions are only for your own benefit. Alright. If you even put the wrong answer, there is no negative marking. In usually I'm talking about okay. In your question paper, check it for yourself. It is given. Alright. It is given the whole time. I think in the screen it has been given the whole time. Like digit type +4 0 and multiple choice +4 -3 like that. So copy this question. Okay. Try it for as long as you want and then restart the video. So it has been given to me. Limit x tends to pi by 2 and the whole thing again. Okay. So but I can at this time I can write a property for it. Sine 3x plus x can be written as what? 2 times sine 2x and cos x. Okay. All divided by what? Again 2 sine 2x sine 3x by 2. Okay. Plus cos 5x by 2. And the other way it is still given cos 3x by 2. Okay. So what can we do? We club those two together. And denominator cos 5x by 2 minus cos 3x by 2. That again club it with. And the first part I can write it 2 sine 2x sine 3x by 2 minus 2 sine 2x sine x by 2 minus under root 2 2 cos square x. Okay. Now limit x tends to pi by 2. So this now pi by 2, 4 root 2. So 8 under root 2, 2 times sine, yeah, 2 sine x cos square x. Only. And in denominator as well, sine 2 sine 2x can be written as 4 sine x cos x, and sine 3x by 2 is over there, and 2 4 sine x. Okay. So over here it will be sine 3x by 2. I'll take this and this common. Okay, so 4 sine x cos x, sine 3x by 2 minus sine x by 2, and minus 2 under cos square x. Only. So 16 under root 2 sine x cos square x all divided by 4 sine x cos x, 2 cos x sine x by 2 minus 2 under root 2 cos square x, and limit x tends to a 0. Alright. So what can we do further? If you can see, I can just cut this cos square term out. Cos square, cos into cos square, and cos square. Okay. Now what am I left with? I'll write it clearly this time for you. I'm sorry for the diagram. 16 under root 2 sine x whole divided by 4 sine x into sine x upon 2 minus 2 under root 2. So now if you put the value for sine x equal to like x equal to 0, what are you going to be left with? I can write it. No, x was equal to 0. I'm so sorry. X was tending to pi by 2 this whole time. Only x tends to a pi by 2. So x tends to pi by 2. I can just solve this one. So it will be 4 into 1 into 1 upon under root 2. And there's a 2 as well over here. Oh, yeah. There's a 2 as well over here. Minus 2 under root 2. So under root 2, under root 2, under root 2, under root 2 will cancel out. I'll be left with what? 16 into 16 divided by 4 minus 2. So 16, 4 minus 2, 16 upon 2, answer is 8. So if you put the value of 8 plus 4. So we can see one more question. Wait, I'm trying to find a question for you that is not based on properties. You can solve after solving the exemplar question. Let's see this question. I think that it is a similar question. I can't say for sure, like, but it seems. Okay. So this is the question for 2020 advance as well. So suppose there's a function going from R to R, and there's a function G going from R to R. The two functions, and they satisfy this condition: fx plus y is equals to fx plus fy plus fx into fy, and fx is equal to x times gx. So limit x tends to 0 for gx is equals to 1. And which of the following statements are true? 4 statements have been given. F is differentiable at x belonging in R, every x belonging in R only. The option is G0 is equals to 1. If this is true, then G is differentiable in x belonging in R. C. derivative of f dash of 1 is equals to 1, and number D is derivative f dash 0 is equals to 1. So it is again an MCQ type of question. Pause this video right now and try it for yourself, okay? Hmm. So I'm starting the solution now. Okay. So fx plus h minus of fx will be equal to sh1 plus fx due to the conditions that has been given to us. If I divide this whole term by h and if I divide this whole term by h. So this I can write it as what f dash of x, and this is what fh upon h1 plus fx. What this? And fh upon h. What is it? fh upon h. See, it is nothing but f0 plus h minus fh. No, f0. Sorry, f0 divided by h. This is the same thing. So this is f dash 0. So f dash x is equals to f dash 0. So it has been another thing, limit x tends to 0 for fx upon x is equals to 1. Since gx has been limit for x tending to 0, gx has been given to me equal to 1. Gx I can write as fx upon x. Okay. So since fx upon x is equals to 1, then we can write f0 upon 0. So f0 is equals to 0. Now, what we had written was, if I leave f dash x upon 1 for limit x tends to 0, and this was equals to what? F dash 0. Now this has come out to be 1.